Hello. Okay, now it's working. Had a little bit of a mic glitch there. Alright, welcome to another Bolo Sound stream. This is part 4 in my series on retro SuperCollider. So, doing algorave and music programming like if we were in 2002 or so. It's getting a bit cold here during nighttime. Have to go get some warmer socks. Oh, hello, Le Jojo La Fruite. Good evening. And welcome. So, I guess I should recap what happened in this series so far. So, the goal is to build a live music performance setup based on SuperCollider 2, which runs on Mac OS 9. And to that end, I have an iBook, which turned out to be a little bit underpowered for doing real-time audio. And then I have another somewhat more powerful iBook coming in the mail that I can hopefully use instead. But right now we're working on my Power Mac G4 desktop, which you can actually see it in the stream there, photo of it. So yeah, I am pretty much continuing from where we left off yesterday. So what happened yesterday was we got a little used to the spawn unit generator in SuperCollider 2, which is very useful for sequencing. Then we started building a pattern abstraction on top of that, because unlike SuperCollider 3, this version does not have a pattern library with, you know, pseq and pbind and all those things. So you kind of have to roll your own. Unless there's something here with a completely different name that I've missed. I mean, that's always a possibility, but either way, I started building my own, and maybe we can have a quick look at what that looks like. So first of all, I'm gonna open the file from yesterday. So this is the actual, this is not the so-called pattern library, but this is a file that uses it. So here you can see a little bit of how you would use this pattern abstraction to write a piece of music. So we have a kick sample, a clap sample being loaded here in quite a verbose manner. Actually, I would maybe like to come up with an abstraction for this to make it a little nicer. But then we have things that should look quite familiar to SuperCollider 3 users. So I define a dictionary with a sequence of notes, and also rests are supported, durations, which can be 0, and that is right now the only way of achieving polyphony in a pattern. So you have a duration of 0 between two events, and that means they're gonna play at the same time. There's amplitudes, there's panning, you know, basic stuff. And then the way you use them is with this function bolo.patternspawn. You pass it the pattern dictionary and a make event function which then receives a dictionary of values for each event. So for example, on the first note we're gonna get a dictionary where there's a note value of just 60 and duration of 0, amplitude 1, blah blah blah. Yeah, and then here you define how that data is actually used. So in this case we have an envelope, which is basically just a release, and then it's, you know, scaling the amplitude of this pulse oscillator, which gets its frequency from the vals dictionary, and that is something that my function now does, that it converts these MIDI notes to frequencies, which, yeah, you can see the inspiration from SuperCollider 3 here quite strongly. And the way this was created was in the SuperCollider folder. I have under default library this bulu.sc class definition. So, you know, here's a bunch of functions. This is basically where it all happens. So pattern spawn, it creates one of those spawn unit generators, processes the pattern dictionary with this eventify function, or method rather in this case. It's a static method of this class. And then there's an eventify raw, which eventify uses, and this basically just processes all the lists without doing anything special, but then eventify has some magic in here, such as the note to frequency conversion, using the duration value to set the next time property of the spawn object, which is what controls the event durations. And then we have rest handling, so if we get a rest, then we don't actually put anything in the event. Otherwise, we use the user-supplied make event function to create a signal, then we scale it by the amplitude. We add some panning if appropriate, so basically we do the smart thing with the amp and pan keys, or their corresponding values rather. And with that we end up with, right now, not a very exciting piece of music, but it works as a demo and it sounds like this. So that is where we're at, and I think this is already shaping up to be a rather nice way of using this to write music. But yeah, there's a few things I would like to do tonight to move this whole thing forward. Not sure if we're gonna get to writing a lot of music yet this time either, but you know, that's how it is on these streams sometimes. So yeah, maybe the first thing would be to clean up this sample handling code a little, because now you can see, well, for each sample we have a path, a sound file object, a buffer, and well, we don't really need the path string after this block here, but we do need the sound file and the buffer, or well, it's a signal object in the case of SuperCollider 2. And why is that? It is because we get the duration of the sample and the sample rate from the sound file object, but then, you know, the buffer has the actual data. So this is something I would like to improve a little, so that we can call something that gives us one single object, and then we can pass that around and get all the relevant data from there. And for that, maybe I'll start by writing a class, and I could call it just sample. Let's actually create a post window, because we don't have that right now. I think, yeah. So now, if I run, for example, this piece of code, then it posts in this window. Right, so yeah, let's create a new file here. This is gonna be called just sample. I'm gonna set this to list. Then we'll open this up in SuperCollider. And then we have to remove this stuff that we copied. Okay, sample. So, what can you do with a sample object? Well, you can instantiate, hopefully one of them. And for that, we'll create a new method, static method. That's what the asterisk is for. It'll take as argument the path, and I don't think it needs anything else. So if we go here and look a little bit at the current loading code. Yeah, so we get the path, and how do you make instance variable again? I think it's something like this for a variable that only gets a getter. Actually, I'm just gonna check that from the documentation. There was classes. Yeah, so getter, setter, getter and setter. Cool. Let's close that. So what we'll start with is window management on macOS 9 is a little bit annoying sometimes, but that's how it is. So yeah, we'll also want to have a sound file and a buffer. Okay, and I need to check one more thing. Is there something special we need to do when making constructor functions? Let's take some example from here. I don't know, collection. There's not even... Wait. There's a call to new, but I don't see where it's defined. Okay, maybe something else. Point. I guess we have to invoke the superclasses new. It's a little bit strange the way they do that. What else is there? Date. Okay, I guess this is just how you do it. Right. We'll copy that and start working with something similar. So we call super.new and we'll actually return that. That's what the caret means. And we'll put path there in its corresponding variable. If you're not familiar with SuperCollider syntax, the setter functions are named like the name of the property and then an underscore, and then this is the argument which, you know, is what the value is set to. Buffer. And here we will need to initialize sound file and buffer somehow, so we're gonna do the same thing that we do here. Sound file, it's just gonna be soundfile.new. You know, why don't I go ahead and just copy this whole thing. Don't really need the typing exercise. Okay, this we already have. So if soundfile.read path, if that returns true, I guess, then we set buffer to sound.data at 0. Oh yeah, now I remember that. Actually, maybe sound file is already quite close to the one object that contains everything, because it does contain the data buffer, and then we index into it like that. But it's fine, I'm still gonna create this wrapper around these things because I have some other things in mind that we can do. Maybe we don't need this instance variable actually. So in the successful case, okay, I'm gonna split this up a little. So in fact, this should only be returned in the successful case, and in the unsuccessful case, we'll just return nil. So that if we have a sample object, then it definitely has successfully loaded. So this, I guess, is it. Oh, we should rename this path variable, and also there's an extra line break here. Right, then I'm gonna make a method called buffer, so this way we can easily get the data. This .sound file .data at 0, that's gonna return the buffer. And then I'm just gonna make some wrappers here, like duration. Okay, that's just gonna return sound file .duration and sample rate. Maybe this class is a little questionable in terms of usefulness so far, but one thing I did want to use this for is having a method which is going to create for us a UGen graph, basically, that plays the sample as a one-shot. So maybe we can call it play one-shot. Does it take any arguments? Maybe it could take... Is it speed or rate in this language? I don't know, but we'll call it rate. Defaulting to 1. And from that we're gonna return this env-gen envelope playbuff kind of thing. This .sample rate. And I have to check what the arguments here are. I think maybe the one is rate. Yeah, third argument is playback rate, so we'll just plug in our argument there. What is the fourth one? Offset. Well, we can take that as an argument as well. Then I'm thinking about duration. So I guess we want that to default to the duration of the sample, but maybe there should be a way to specify that as well. So that will default to nil, and then we can do like this. Yeah, I don't know if this abstraction is like a super good idea, because I guess conceivably in many cases you would like to tweak the envelope, maybe even some of the looping parameters. Well, that's not a one-shot then if you're looping, but here one thing I'm thinking. If we pass in a duration that's longer than the sample duration, what should it do? Right now it's gonna start looping. Maybe that's fine. Okay, let's try that. calculation done. Okay, so we'll get rid of all these variables that we had. And instead, we're gonna do like this, and then the same for the clap. We can remove all that. And now here, because this was the annoying thing with the previous setup, I was mapping the note index to either the kick or the clap, and because the buffers and the sound files were separate, I had to do this twice. Well, disregarding the fact that I could do .data.at0 on the sound file, but I'm now just gonna write like this, remove this line, and then we can replace all of these like that. Oh, and also we shouldn't have this at all, the engine, because now we can do play one shot. And I already forgot the arguments. So why did I close the file? Right, rate offset duration. Well, we'll just use the defaults for now. Also, here we could get rid of the sample variable, but I think this is fine. Now let's try this. It does not work. Play one shot. Oh, I guess if you're not passing arguments, then you don't put the parentheses. Path not understood. Okay. So that would be here. Oh, so if we don't have the setters, does that mean we can't even use them internally? Interesting. Yeah. I seem to remember there's like an idiomatic way of handling this in SuperCollider 3, but now I don't remember the details. Maybe I can look at some other classes just in case. Okay, I remember actually. So I think what you do is have an init function which sets the values, and you should be able to do that without setters. So we take path, sound file, buffer. We do this dot path equals path. This dot sound file equals sound file. This dot buffer equals buffer. And finally, I think we return this. And now instead of this, we can do init like that. Still not working. Is it the same error? It kind of looks like it is. Yeah, path not understood. Okay, we have the same problem. Well, maybe we just have to put in the setters then. Was there something about like private methods or whatever? Okay, I give up. I'm just putting in the setters. Oh wait, one thing to note here is that we don't actually have anything called buffer. Could that have been the problem? I'm just wondering, because it seems like you should be able to have just a getter and then still some way of assigning that value, because otherwise what's the point, right? Like some way of assigning it from inside the class. But the error is about path. Well, it's fine. I will put in the setters and give up on encapsulation ideas. Not that it really matters in this context. Okay, is that better? Yep. Okay. Well, that's a slightly easier way of loading samples. And I'm actually gonna put this folder path in a variable, because we might have more of that. I wonder if this version of SuperCollider has like a path concatenation. What was it called? Something like this. No, I guess not. We will just do it manually. And in fact, if I put the colon at the end there, then it's just a matter of saying, is it plus or plus plus? I always forget which is which. Okay, so plus puts a space in between, whereas plus plus does not. Yep, still works. Okay, and with that we've further cleaned up this code a little tiny bit. Okay. Then, something I talked a little about yesterday is how in the initial song, or beginning of a song I made with SuperCollider 2, I had a way of turning on and off patterns using OSC. So like with an external controller. That of course is very useful for live playing. So let's go back to that code and see how that worked again. So that was, I believe, in Untitled 2. Really great name, I know. And oh, this cannot be drag and dropped because macOS 9. Oh no, it was actually the other one. Here we also have some of these rescaling functions that it might make sense to put in the class library. And here I had a way of defining the OSC mapping. I'm thinking this is probably also code that I wanna reuse quite a bit. So what this does is set up arrays of refs, and refs are things we can read inside a synth. Like while it's playing, but I wonder. Okay, let's try to do something a bit simpler for this file first. So for that, what do we need? Let's start by making something like this. So we're gonna have the OSC tree. I'm gonna keep my camel case consistent here. right now I really only care about this first line. So run here was a array going from I think 0 to 11. You know, actually, maybe I'm not even gonna do the whole array thing here. I'm just gonna start by putting, probably it's bt0, and then a function that is run whenever that address is whenever a message on this address is received, so mft1/bt0. I think this gets as argument just a node and val. So val is really what we're interested in right now. For now, we're just gonna post the value of that. Let's try this. Nope. Do I have... I don't remember exactly how the array structure is supposed to go here. So this would be an array, and for each entry in the array we would get an array of 2 elements. Okay, so I have not enough arrays. Something like this. I'm just gonna mute this for now because we don't care about the sound right now. But now I should have something something controllable. So okay, I have this Touch OSC patch here on my phone. So now if I press the very first button on here, then we can see that we get the 1 and 0 for pressed and released. So that's good. And the question then is, how do we handle muting these things? So yeah, probably we're gonna need the refs again. I'm just making one for the moment. It's gonna start off like this, having value 0. And I'm gonna... Okay, maybe add some line breaks here. So I'm just gonna write the value for now into bt0 ref. And then how did I use the ref again? I think. Okay, something I wonder about, does this actually have to be a ref? What if I just set it to an integer? Also, I don't think this is the right way to set a ref, but that's fine. But okay, now it's just an integer variable, and I'm gonna set it on each OSC message, but then does that enable me to here, if I comment out a bunch of stuff, so these other patterns, I'm just gonna test one pattern for now. So can I now add a conditional which would go something like if bt0ref is greater than 0, only then would we return this whole envgen structure, like the actual thing that makes sound. Let's try that. Okay, that did not work. Message multiply not understood. Oh, and that, I guess, is gonna be because we are doing a multiplication here in what is this called? Pattern spawn. Yeah, so we're not handling the case here that make event returns nil, which it would right now. But that's no problem. We can add another conditional here. So if sig is not nil, then we just well, if it is nil, then we just skip the whole thing and don't try to multiply it by anything. Okay, can I compile? Yes, and let's try. So now we have playback, and now what I'm expecting to happen is that if I hold down this first button here, then it should play while I do that. And if I release it, it stops. And we can see here that unlike the old version where I did all my sequencing inside the synths and then just muted things that were not supposed to be playing, this actually uses less CPU when I'm not holding down the button. So this is looking promising in terms of, well, reducing unnecessary CPU load, right? And that is pretty cool. We didn't even need to use the ref. I guess that's because we're not trying to read the value like as a signal, basically, something that could change during the runtime of this event. So it's fine to just have a regular variable. Okay. So then I will start thinking about how to put this again in my library code. It's kind of not great practice to shove a bunch of stuff into one class, but I'm gonna do it anyway. Or am I? Maybe I am not. Yeah, I'm not gonna do that. I'm gonna make a new class called I guess it can be MFT-OSC. So that's MIDI Fighter Twister. The name of my MIDI controller, which this OSC patch is emulating, and also it has the ability to convert incoming MIDI from the controller to OSC, so it actually reaches SuperCollider 2. To which I cannot directly connect my MIDI controller because there is no OS9 driver for it. Okay, so we're gonna start by defining a new method. It will take as argument the input port, I guess. Now that I think about this, okay, maybe this should be because I'm thinking, should this class hold the logic to track the playing state of different patterns? So should it have the flags that say, okay, pattern 1 is playing right now, pattern 2 is not? Or should this be more generic and then I implement that on top of this? I maybe don't wanna implement or even think about the more generic version right now, but then the name maybe needs to be something more specific. So I will call this MFT pattern controller. That's very long. I'm just gonna go MFT pat control. Okay. Window management, so fun and interesting. Okay, so what does this contain? It contains the playing state of each pattern, and there are 12 patterns. Maybe that's actually my first variable. Num patterns, that's just 12. Maybe that can have a getter. So yeah, now that I think about this thing that I was talking about before, maybe the use case here for variables with just a getter is like constants. Who knows? Num patterns. Then there's gonna be an array of booleans, 12 booleans more specifically, which holds the playback states. I'm just gonna call it playing. It will have getter and the setter. I'm just thinking, do I want to access this directly from the outside or via a method? Probably it's fine to do it directly. So in here, okay, we're also gonna need to store the, I mean, maybe it's not strictly necessary, but I'm gonna do it. Store the OSC port object. So what was it? Super.new. Then we set OSC port to OSC port, which we don't have yet, but we will soon. Playing, same goes there. Just a second. Yeah, so OSC port, that's gonna be OSC import, and that will use the import argument to specify which port we're running on. OSC tree, which is not a thing yet, but it will be soon. And playing will be, how did I do that? I think it was array fill in the older code. Yeah. There really needs to be a way to move between windows using the keyboard, and maybe there is, but I wonder if the send, okay, so the send to back command is kind of that. It's just a very awkward key stroke combination on a Finnish keyboard, but whatever. We don't use the argument here, so let's just do it like this. And yeah, OSC tree. This is the most complicated part of this. And also I'm copying from the wrong place. What I meant was the one here. So I think the indentation goes something like this. Okay. So we don't have this run thing. Oh, actually we need playing before this. And also we need to declare these variables. Or maybe we don't need it actually before, but whatever. Oh yeah, we do. So we do playing.collect. This is not a ref anymore, so it's just gonna be a value. So for each index in playing, so from 0 to 11, we create the symbol BT followed by I, so BT0, BT1, and so on. And we had this run on press function, but maybe we don't need that. Instead, it will be okay, yeah, so this actually is a function, and the run on press function creates one of these OSC listener functions. But I am gonna split this up on multiple lines so it's a bit more readable. So what this functions you should do, so this is the function that is run whenever we receive BT0, BT1, and so on message. And we know the number because we have the I variable, and we should not call this val, it should be playing. No, because that's already a variable. Just play. We're not even gonna use this variable, so it's a little bit silly to have to give it a name, but hey. I'm gonna add more line breaks and more indentation. So what we're gonna do is I guess we want to set the element at a particular index. Now I'm not sure how you do that with an array. Let's try that. So we have X is gonna be an array. We fill it, let's say 12 elements, 0. Then do we run put or yeah, okay, put seems to be the right thing. So playing.put yeah, but here's the tricky thing. Okay, for now we're just gonna toggle the value whenever the button is pressed, and actually we need to detect presses from releases. So val is gonna be 0 when we press, and val is gonna be 1 when we press and 0 when we release. So with this check, we can run this code only on press. And for now, let's just toggle it. So we use the index I, and then we take the old value with playing at I and we negate it. Oh, and also these were supposed to be booleans, so false instead of 0. And I will ignore these for now. Does this look reasonable? I think so. Maybe we can add a bit of debugging code in here, just, you know, post the value of playing after we modify it. Cool. So compile. Oh, and actually I just noticed we have a warning here. So there's something that will not be inlined because of how I've structured the code. So it's seek equals make event. Okay, so probably we should move this sig declaration to here. No, sorry, here. This is a thing you still have to do in SuperCollider 3, where it'll warn you about things not getting inlined, and then you have to shuffle your variable declarations around. But it's nice that it warns you. Yeah, no more warning. I'm expecting this to now run super fast compared to before because of this one little optimization. Maybe not. Okay, where was I? I was here and then here. No, here. So now instead of all this stuff, I will simply... Okay, let's give it a name. MFT, or why not even patch control or simply control? MFT path control dot new and port 8000, and we'll keep the OSC port close all so that we start always with a clean slate. But now we cannot use this anymore, so let's get rid of it for now. Actually, I'm just gonna comment it out because we're gonna do something quite similar in a moment. Okay, does this work? It does. And now if I press the buttons here, you can see with the first one I'm toggling the first pattern playback state from false to true and vice versa, although it's not actually affecting anything right now. Then with the second button it does the same for the second boolean and so on. So that's exactly what we want, and now we can go back here, and instead of this check it's just gonna be if control.playing at 0. Oh, right, yeah. So we only have this at indexing, I guess, which is kind of ugly, so maybe I'm gonna turn this into a method after all. I'm gonna call this play state instead of playing. Then I have a bunch of renaming to do, which I could do in 1 second if this was Emacs, but it's not. Play state, maybe it should even be play states, but Okay. And then it goes in here also with the same name. And then we can declare a method playing, which will take an argument, I, the index, and just return this dot playstate dot at I. So now this is a little nicer. At least I think so. Okay, let's recompile. I made a typo there. Let's try that again. Compiled. And now actually before we try this, I'm gonna add back in the other patterns and we'll wrap them also in a similar conditional. So we can actually control all of our patterns now. And that should be 2 instead of 1, or instead of 0 rather. Alright, let's give that a try. Okay, it starts up successfully. We have a little bit of CPU usage while nothing is playing, but now if I start to bring in patterns, yep. So there we have a little performance system already, which is pretty cool. Now, I'm thinking this play state checking could also be part of pattern spawn. So how would that work? Now if I think about this, maybe we're gonna need refs after all. But my idea is that we would have another key here. What should it be called? Maybe enable. And now the thing here is that each one of these values now is supposed to be an array, but in this case, does it really make sense to make a pattern of things that determine whether the pattern should play or not? I'm not quite sure. But okay, let's accept that that could make sense for a moment. And then what would we actually pass in here? Because it would have to be something like control playing 0, right? But now this is going to be only evaluated when we create the dictionary. So either we have to pass a function here, which is then gonna be evaluated every time, or if our playing values were refs instead of like plain booleans, maybe we could just do this. I just worry that, like, I like the function approach. It's simple, but I just worry that it's gonna have some overhead. Not sure if it's gonna be significant, but okay, I'm gonna implement the initial version this way. And I guess there is some maybe interesting stuff you can do if you treat this as a pattern. I don't know, but okay, in this case we would get rid of these things here. And we'll go back to our pool class and the eventify function. Now let's take from here do we actually need to make it a variable? Maybe not. Whether we're enabled or not, we need to set spawn next time, so this needs to happen afterwards. Maybe we can just add to this conditional here, so that, okay, if we take now, what is it, vals at enable, and then because it's a function we have to call value on it to get the return value. But actually, no, this should go in its own conditional, because there's a little bit of optimization we can do that way. So if vals at enable dot value because if we do it this way, we can skip the frequency calculations and everything if the whole thing is disabled. So then this code goes inside here. Yeah. Okay, I think that should actually work. Compile done. Let's try try playing. Okay, and now try enabling some patterns. Yep, that works great. All right. It didn't seem to add any CPU load, at least just from looking at the numbers. So yeah, that's quite cool, I think. Now, if we had our patterns in an array, we could add these enable things automatically, but maybe I won't bother with that right now. Then one more thing that I want to do, there actually are two more things that I want to do with the controller class. Number one, don't toggle just by pressing the buttons, but instead I have a separate stop button. So the idea is if I hold the stop button and then press one of the pattern buttons, then it disables them. But if I just press one of the pattern buttons while it's playing, then like it keeps playing, nothing happens. So yeah, let's start with that, and we actually already have some good code for that here. So we're gonna need a new instance variable. We'll call that stop mod. So mod is for modifier key. So now we handle this button 15 presses, and we'll set this dot stop mod to true or false depending on whether it's pressed or not, and then we can look at that in here. So now this is basically what's doing the toggling right now. So instead of this, we will use this dot stop mod dot not. So what does this mean? So if stop mod is false, that is we are not pressing the button, then of course not that is true. So then we want to play the pattern. If it's pressed, then it's going to be true, and the not evaluates to false, and then we don't want to play the pattern. Okay, compile. Try to run. Now if I play a pattern, okay, that crashed. So presumably I made a mistake. Message stop mod not understood. How come? Oh, what is this at this point? It's probably nil, right? No, it's not. Wait, what? I'm gonna just try something. So without this, it's... Oh, actually, one thing I forgot to do was set the value, the initial value of stop mod, which of course is going to be false. Yeah, that kind of makes sense. Let's try that. Is that enough to fix it? No. I'm just gonna clear this and try again. Yeah, stop mod not understood. So I think that this that is in scope here is probably like the class and not an object of it. Maybe. Okay, how do I need to structure this? Maybe I gotta do it so that... Okay, I'm just gonna create a variable called control and store this whole thing in there. And as our final step, we're gonna return control. And we're not gonna set OSC port here. We're gonna do it here, and in between those things is where we make the OSC tree, and then instead of this, we're gonna use control here. And actually, we should probably qualify this as well. I mean, it's maybe not gonna matter really, but... So, this is control. Are there any more thises in here? There's probably a more idiomatic way to do this, but... maybe using the init function that I was thinking of earlier. You know what, let's try that. So, instead of what I'm doing right now, we would return super.new.init. Import, I think, is the only thing we're gonna need in there. And that's the end of that method. I'm not sure if this is gonna work, but let's try it. So import. Now we shouldn't have to do this. We have a actual this variable that we can reference, and we're gonna take, oops, these things out of here and put them in init. So we make play state, we make OSC tree, and now we go back to saying this. OSC parts, yeah. And actually, at this point we don't even need the intermediate variables. We're just gonna do like so. And then we can refer to it from here. OSC tree can be a temporary variable here. And this OSC port becomes this OSC import. So we can get rid of that, and also of course this control variable. Let's see, that looks fine. Although wait, what? We don't need this line at all. Then I guess we just return this. That might even be the default if you don't return anything, I'm not sure. Well, let's try that. That's a compilation error, I think. No, it's fine. Okay, still have some issue. Message not understood. Okay, so we're making progress. It's a different error. I think that's just because we did not initialize stop mod, so it starts off as nil. I'm gonna put these in the same order that I actually define them, just because that makes me feel better. And here, instead of the literal, we should use numpats, which we declared earlier. And yeah, here is where we need to initialize stop mod with the value false. Okay, recompile, that's fine. Alright, now this seems to work. So I have pattern 1 or 0 playing. If I press it again, it keeps playing. I can play the others. Now, if I hold the stop mod button here and press patterns or button 0, yeah, it stops. Great. Great. Then the final thing that I want here. So, as you might know, the MIDI Fighter Twister is a controller where the buttons double as knobs, or maybe vice versa. So you have these knobs or rotary encoders, and you can press them. So now we've been dealing with the pressing part, but this Touch OSC patch of mine also has emulation for the knobs in the form of these little sliders above each button. So we're gonna wanna handle the messages from those as well. And how do we do that? Well, there is already some code to do it from the previous version, but we're gonna need another instance variable which will hold the knob values, and in that I think we're gonna use refs. So for that I can actually just go back to this code here, borrow the initialization, so this .knobs is gonna be another array fill, but this time we're making a ref. Don't need the index there either. And okay, what then? Then we need to add this to our OSC tree. So we're gonna collect over this knobs. Again, add some line breaks here. And this, I think, is gonna work just the way it was. So we still have refs, we set their value whenever we receive a corresponding knob message. And I think that is it on this side. Also, I'm gonna now remove the debug print here, or post as it is in SuperCollider lingo. So that is hopefully the entirety of our OSC tree. Okay, compile done. Now, how do we test this? Let's make a couple different things to try this out. Well, okay, the easiest way, of course, is to just add a volume multiplication or gain multiplication. So yeah, let's start with that. So, oh, actually, I guess we do want a method here to get the value of knobs at I, or the reference rather. And when we want to read a ref in synth code, I think we need this plug.kr. Yeah, probably in this case we could actually get away with not using plug, but instead just taking the value, because yeah, that would mean presumably that we get the latest value every time, once per each node basically, whereas if we use plug.kr, then we can tweak the volume even during a node, I believe. Maybe that's something we could try out in a moment. I'm not actually gonna put anything here. I am gonna put it here control.knob 1 dot value maybe. Then here, if you remember, our first parameter is the playback rate. So let's have a way to tweak that by... Okay, so now we have a value from 0 to 1. Let's add 1 so we get a value from 1 to 2. Yep, that hopefully works. Let's try it out. Now I'm gonna start by enabling all the patterns. And we don't hear the second one because of the multiplication by the knob value here. But now if I start to bring in the knob, then we should start hearing it coming in. And yeah, now if I take it down to 0 while the note is playing, it doesn't affect that ongoing note. Whereas if I do it this way, I think it will affect it. So yeah, you can hear it's totally real time in this case. Oh, and I guess we should try out the drum rate control as well. So if I start to increase that, oh, there's actually a little bug in our play one shot function. That is quite obvious now that I think about it. So if you go into sample, we have this duration here, but of course if our rate is something else than 1, then we need to adjust this duration accordingly, scale it, that is. So, okay, if we have rate 2, then the sample plays at half speed, so it is twice as long. And therefore we need to multiply by rate here. Wait, what? No. If we have rate 2, then it plays at twice the speed. It is half as long, so we need to divide by rate. Yeah, of course. So let's try that again. And I'll mute the other two so we can really hear it clearly. Yep. That's good. I do actually wonder if negative rates are just gonna work. Probably we need to use this dot neg for negation. So let's try playing the drums. Okay, I don't hear anything. So maybe that's because the offset is 0. So if we wanted to do this, we would have to change the offset to make it start at the end, I guess. Is the first parameter even offset? Yeah. That still doesn't work. I wonder if there's like a... Well, first of all, I wonder if the units of the offset are in seconds or in samples. Right, sample offset. So that does sound like number of samples. Okay, so then instead of this, instead of this, we're gonna have sample buffer size, and we might need to subtract something from there, but let's try this first. Yeah, that doesn't work. Let's try to subtract 1. No. What about 2? No. It doesn't want to work in any of these ways. I'm sure there's a good reason for that, but what would that be? Weird. Of course it's because this becomes a negative number. So I'm just gonna have to use abs here. Right, okay. Yeah, I'm pretty sure that was the issue. So now if I try this again. Still nothing. Well, let's try the offset again. So that was sample.buffer.size. Let's start by 2 because that's what they're using in the examples for the loop point for some reason. No. Wait, did I recompile? Maybe I didn't. Okay, yeah, works after recompiling. gonna have some fun and make the control go from -1 to +1. Wait, I don't need the negation there anymore. So now we can go through 0 and then go backwards. Yeah. Have a bit of fun with that. Okay, yeah, that is already some decent progress. Yeah, now I'm thinking of doing the thing I talked about earlier, where I actually combine my patterns into an array and then get some stuff automatically from that, such as the enables and maybe also mixing or summing at least. But actually, I'm gonna take a quick break. I will be back in a few minutes and let's see what we'll do after that. Hello, I am back. So, what I would like to be able to do is something like I guess I would like the data structure to bundle together this pattern and then the corresponding make event function. Okay, let's make a variable path data, and that's gonna hold it's gonna be just the normal list. So the elements are gonna be these things, but then we want to associate the make event function with this, and maybe for that I'm gonna take advantage of this mapping syntax. So in this way, we basically get a, well, it's essentially a tuple, but with a kind of cleaner syntax. We don't need the surrounding parentheses, for example. Then we'll do the same here. No, wait, that's wrong. It goes here. Add a comma. Indent a little. And our final mapping using this make event function. And we'll end the whole thing with a square bracket. And now, given this path data, I'd like to say control dot, what should we call it? Play patterns. And path data. Right. So this makes our code inside synth.play very simple. And also the idea here is, like I said before, that we could now get rid of these. So they would be added automatically by the play patterns method. So how do we start implementing that? Well, we go in here and we start typing display patterns. I'm just gonna call it data in here. Okay, now I need to check. So if we have a mapping like this, can we call key on it? And then maybe value. Yeah, okay, so that's nice and simple. Yeah, so data is an array. We'll collect over it. Each element, or for each element we get the KV, which stands here for key value, so this whole mapping of the pattern and the make event function. And then we get an index as the second argument. That's gonna be useful. So, okay, first of all, let's just try mixing these. So how did we do this? Bullet dot pattern spawn. And we get the pattern and the make event. Which is just the key and value of KV. And hopefully we can simply sum that. Let's try that. Okay, there's a parse error. Oh yeah, we need the parentheses here. There we go. Now hopefully this will do it. It will not. Non-Boolean in test. Eventify. Oh yeah, this could be nil, in which case we cannot call value on it. Well, we can, but then it's gonna give us another nil, and oh yeah, so if this gives us nil, then we'll default to true. So now patterns that don't have an enable specification will just play by default. Okay, I'm just gonna change this back to this thing so it sounds a little nicer. Cool. That works pretty well. Then we want to add those control things. So the enable mappings depending on the corresponding value in the playstate array. Okay, I'm gonna make some temporary variables here. This will be pattern and make event, and then we'll just kv.key, just because it's a little clearer what is happening. So now we want to manipulate pattern, and we're gonna check if pattern maybe we'll add another variable. So enable is gonna be pattern at enable, and if that is nil, that is there has not been an explicit enable mapping given, then we create a default one, which is it okay to modify this dictionary here? I'm gonna say yes, and simply add enable. That's gonna be an array of a function, and the function will call this dot playing of I, which remember we're getting from the collect. Okay, let's give that a try. Oh yeah, we have to compile the class first. Okay, that did not work. Key not understood. Receiver symbol enable. Oh yeah, I guess this needs to be a mapping. Okay, it's running, and now let me get Touch OSC on here. That is not working. Interesting. So why is that? Let's add a post line here, or actually, okay, I'm gonna make this a little longer for a second. Var, what is it? Call it play. This playing, and we're gonna return play eventually, but before that, let's post this thing. So now all of these are full. Wait. Oh, it's actually working. Well, that's nice. That means I can go back and remove all this stuff. Okay, let me just verify that it still works. Yes, indeed. So, that's pretty cool. It means we can write stuff like this and just have the controllability magically added instead of having to worry about it ourselves. Like, the syntax here is not too bad either. It's like the arrow kind of makes sense here, right? So this pattern of events leads to this synth, which gets some values derived from the events. So yeah. Where do we want to go from here? Oh yeah, there's one other, should I say, piece of magic that I was thinking about. I'm not sure if it's worth implementing, but okay, I'll explain the idea. So, as it is, we have to write things separately, such as note and duration and amplitude, when in a way, well, in some scenarios we might want to write them together, right? So that one note has the MIDI pitch value 60 and that note has duration something and amplitude something, instead of like having to match them like the indices. And of course this doesn't apply in this case where we have different lengths of these arrays so that they kind of so this amplitude can or will apply to other notes than there's this 60, like it's every fifth note from this sequence gets the amplitude one, right? And that's cool, but that's not always what we want. Like if you're really writing a melody that in a more traditional way, so not really caring about generative techniques, then you might want to bundle some of this information together. And I was thinking of doing that in what maybe I don't know if it's a good way, but it's just something I had in mind. Okay, let's add a fourth element so I can demonstrate. Dictionary. Okay, first of all, I'm gonna write the synth. What do we want here? What other oscillators do we have than pulse and saw? I guess there's one with a sine wave. Eugen ref sheet, maybe? Or actually oscillators here would be more appropriate. So we have os, which is a wavetable, sine os, fast sine oscillator, yeah, but this had the issue that the amplitude will vary with frequency. Well, I'm gonna try that out. So f sine ask, and that's gonna be vals at freak, not pitch, and yeah, so let's write some kind of melody here. What is this? 73. This is probably not gonna sound good yet, but let's keep working on it. Duration. Something like this. Let's see how that sounds, or hear rather. It crashed with what appears to be no error message. Oh, it came in here for some reason. Let me check. Post here always. Okay. Try that again. Object does not understand. Wait, it's a different thing. Perform binary op failed, so somewhere we are trying to multiply nil by something. Wait, is this just that we need to have an amplitude defined? That's maybe something I should fix. Also, why not put it right in here? Okay, now it doesn't crash, but I'm still not hearing it. Actually, no, none of the patterns seem to work. That's weird. So it is receiving the OSC and the play states are being set correctly, but for some reason this broke the whole thing. Let's try to comment it out. What? Wait, volume minus 63 dB. Did I think I must have accidentally hit this key combo. Okay, well, fine, how do I restore the volume? Isn't there like a reset thing for it? Well, yeah, I can't adjust it from here. Is it like the system volume? No, that's on maximum. So it is SuperCollider's own volume. Maybe. Okay, if I try to boost it. Like so. Okay. Then we bring that pattern back. Yeah, that does not sound very good. This is definitely not what I meant to write. 75. Let's just get started with that and also decrease the decay here, or release. Okay, that is at least in tune. still gonna decrease the release here. Yeah, that'll do as an example. So yeah, the thing that this was leading up to is that what if instead of this we could write this as something like this instead. Like that. I think semantics wise, I imagine it's quite clear what this means. So like, instead of specifying nodes, just nodes or just durations, we're specifying both at the same time, and that then gives this kind of structure. And this is of course not gonna work right now, but I think making it work should not be too hard. To do that, we're gonna need to tell whether a value is a list or a collection or not. So let's see. I guess there is like an is list. Or not. Okay. Is array. Ugh, what is happening? Okay, there's not something like that. Is collection? No. Do we have a type method? Doesn't look like it. Get type. No. Okay, what about size? Cause this now... No, I'm gonna do this so that I can always see the post result. So yeah, for scalars we have 0 size. I guess strings have a size that's their length. What about symbols? That's also 0. We could work with that. So a collection is gonna have a size greater than 0. Well, not necessarily if it's an empty collection, but I think we can work with this anyway. Empty collection is not something that we really need to support, because what would even be the meaning of that? Nothing, if you ask me. Right, so we go back in here. Look at our eventify function. So all of this should happen pretty much as the first thing here. So we'll do a bit of pre-processing, and how will that work? Wait, no, this is not, I think, the right place to do it. Or is it? No, it needs to happen before we call eventify raw. Would it actually make sense to do this in eventify raw? Kind of not. It is very like a general expansion, but raw also means raw, I feel like. So let's do it here. We are gonna... I guess we'll just loop through the keys, so we get pattern.keys.do, and we're gonna have the key. We might actually need to make a whole new pattern. So we'll call this pattern expanded, and that will be what goes in here. Okay, so we'll loop through the keys, and if the key has size greater than... I guess it's gonna have to be greater than 0, because we could technically do like, you know, this. It doesn't really make any sense, but it's kind of... or it makes sense, but it's useless, but it is like semantically sound, so let's support that. If key size is 0, then we'll do an expansion, otherwise we will just add the thing that already exists in there. I think after this I'm gonna want to post this dictionary, the expanded one. Okay, so what do? We now because we have a key that is a sequence, we will just loop through it. And okay, here is where I would like to name this key again, but okay, I'm gonna call it sub key, and then we get an index. So for each key, or rather sub key in the key, we're gonna add something called values. And what is values? So values is gonna be something that we get by working with pattern at key, but then we collect over that arg. We get val, and I guess we'll call this j. Or, okay. Yeah, sure. Let's have it like that. And now val is also an array. So we will get from there the element at... Wait, we don't need j here actually, so we'll get the element at I, which is the index of the key. So this is basically unzipping the list here. Yeah. That I think should do it. Let's compile. Now, does it work? Let's remove that. And okay, it did not work. For by not understood. What does that mean? Scan for... What? Wait, did I use the wrong... the wrong function again? I don't think so. So what is happening here? We are adding something, but which one of these is it? Now I'm confused. Let me take this code and try to play with it in a more limited context. Pattern is gonna be dictionary. Okay, well, first of all, we can try the empty dictionary. Indentation here is a little wrong, but you know, actually, I'll just indent everything. Yeah, pattern expanded needs to be defined as well. Oh wait, should I be using dictionary new instead of these? That might actually be the case, but let me now add something. Okay, that works as before. Or rather, that comes through without any modifications. Now, if I have this, that does not work. So the failing add call is this one. For by not understood. Let's print. Actually, we can just add a post line here. That's not posting anything. So why? Okay, let me try to post just this. Wait, is it failing already at the initialization of the dictionary? I guess so. So in fact, this may not be possible at all. Okay, so it seems like we may not be able to use lists as, you know, dictionary keys. That's a little unfortunate if it is the case. Like, we can have the association, but then creating the dictionary is a problem. Okay, but what if instead it wasn't a dictionary and it was just an array or a list of associations? Because now we have to create the dictionary anyway when we're doing the expansion. So that might actually be nice, because then we save a little bit more on typing. dictionary.new, and then we cannot iterate through patterns. We'll have key values here. Var key and val, I guess. No, but we are already have that. Just trying to come up with good ways to name things. So basically we're replacing this thing here with whatever this variable is can be called. Okay, I am gonna call it val, and then this becomes val, and this becomes subval, just like we had. Subkey earlier. Okay, now hopefully this should work. But maybe not. So we posted something that was the dictionary. No, that's something before that, I think. Wait, what are we posting? I'm getting really confused now. So... oh yeah. Of course we need to initialize or assign these variables instead of just expecting them to magically gain values. Also here, this should just be val. In fact, we could even just put kb in there. See, now we're getting somewhere. But... oh yeah, this is correct. So, what I really expected here was this. And that now turns this trivial case into the right thing. So, basically we unwrap the arrays, then if we have a b here, let's try that. What? I think the post may have gotten broken there. Yeah, okay. That is the correct logic. So let's bring that back into our class. So we do that, we compile. Now I think we can remove this testing code. And now try to run this. Nope. Right, because, yeah. We still have dictionaries here, but that's not what we want. working. Clear that and try again. Enable. Okay, where is that? In play patterns. That's in MFT pad control. Right, because now we are here we are trying to get the value at enable from this pattern dictionary. So basically, we would really like to have the expanded dictionary at this point. Okay, so then maybe this is actually the wrong place for this logic. Yeah, let's yeah, let's put this in a separate function, or method rather. I'll just call it expand. Call this pattern list. Yeah, and then we're gonna expand it right here. Expand is really too generic of a name, especially considering where this function or method is. Pattern expand. Now that should possibly do it. Okay. Not quite. Oh. Colon instead of semicolon. and we need to declare that variable. Do we still have the declaration? Here? No. Good. What about... Yeah, okay, this is fine. Compile, try to run. Okay, now it didn't crash immediately. I wonder what these falses are. Well, now I'm trying to play the patterns, but nothing's happening. Volume is now at 0 dB, so that should be fine. So where did we have a post? Yeah, I don't actually know, but let's put a post here. Oh, now it's somehow started working. So here we can see that our pattern has indeed been expanded. Okay, let me just look for post calls. Nothing there. Yeah, there's this one, but... Oh yeah, that one. So recompile. Okay. And now the cool thing about this is that we can, of course, combine any number of parameters this way, so that each node can have any number of things associated with it. So we could, for example, say something like this. I think it's working, but the difference is maybe not drastic enough. Yeah, works just fine. Okay, now I am thinking the way I've set up this structure has some issues. So it is of course very compact to write now, but it has come at the cost of some flexibility. For example, let's say we wanted to have a delay after this synth basically. And now that we are using this play patterns function, there really isn't any way to do that anymore. So what can we do? I'm thinking we could write something like this. And then in would be the signal coming out of the spawn, which runs this stuff. And then here we could wrap it in whatever code we want. Okay, first of all, what is the associativity of this operator? I guess everything in SuperCollider is left associative, yeah. So how would we work with that? Thinking. Yeah, I guess this would be the place to deal with that. So we're gonna need to change this up a little bit. So now we're saying pattern is equal to kv.key, but kv.key is not necessarily the pattern, and also on an unrelated note, I'm gonna put this call here. No, I'm not gonna do that actually, because this is gonna work better in a moment. So okay, what are our cases? Our cases are that we have only the pattern list and then the make event function. That's one case. The other case is that we have those plus the, what should I call it? The insert effect, maybe that's a good name for it. So in the latter case, we have in kv kv.key is gonna be another kv, so that's basically what we need to detect. Okay, and how do we do that? Of course, we can check whether something has a key, but then yeah, we cannot call key on a list, for example, which would be the thing to do here. Okay, so is there something like has key? Probably not. Is there a way we can check for the existence of a property, or I guess a message on the receiver? Let's look at object. Okay, response to. And also here's a lot of other useful stuff. Yeah, I should really go through that at some point to really gain a deeper understanding of the language. But what we need now, I guess, is response to. So does this respond to key? Well, yes. But then a list, for example, does not respond to key. Well, that's, I guess, all we really need to know. So we'll go in here and ask kv.key whether it responds to key. Okay, here I'm gonna need to comment this a little bit. Check whether we have a list or pattern make event make effects, or just pattern make event. So if kv.key responds to key, then we are in the former case, and otherwise in the latter case. And we're gonna need to declare make effects, and in this latter case, pattern becomes kv.key, and make event becomes kv.value, and make effects is gonna be nil. However, in this other case, pattern becomes kv.key.key, make event becomes kv.key.value and make fx becomes kv.value. And I think there would be a way to shorten this a little bit, but I'm not gonna do that now. Okay. Then we're gonna call this sig, and we will eventually return sig, but if make fx is not nil, then we will call make fx. We'll reassign sig to the value of calling make fx with the current value of sig, and hold on. Okay, the problem now is that we don't have access to the wait. We're not gonna be able to have access to the vals here in the first place because this is gonna be outside of the spawn. Okay, well that's fine. Then we don't need to worry about that. So yeah, all we do is pass sig in here. And that should do it. Let's try to compile. Yeah, that's fine. Okay, super basic check. I'm just gonna do the identity effect, so to speak, so the effect which does nothing except pass the input through. And we'll see if that works. Yep. Then let's see. We have delays, for example. We can do comb n. Actually, let's I think we'll put it like this, so we have a dry portion and a wet portion. What are the parameters? Okay, max delay time, let's say 1 second. Let's say 3 times 0.15. Decay time, 3 seconds. Actually, I'm gonna go 2 times here, because I think it'll clash with the rhythm otherwise. Okay, that didn't sound great, but it is adding a delay. So if I add maybe one more note here. So that way we can now have effects on our thing. However, does that make sense? Yes. Yes, I was thinking, should the delay be disabled when the pattern is disabled, but I don't think we can do that because we're checking the disabled state inside the spawner, but we need the delay outside, so yeah. Yeah, this is not a great track still, but I think the best part of this is actually the little sine wave line we just came up with. Even though it's very simple. But yeah, as a tech demo, it works just fine. So, what then? Oh, thank you for the follow, Dark Clouds Anywhere. Oh, Dark Clouds Anywhere says this sounds nice. Well, thank you. It is so far just basically a tech demo track to demonstrate what we can do with these pattern abstractions that I've been creating here. Yeah, I don't think I'm gonna compose a lot more tonight, but I'm thinking there is maybe one more feature I would like to implement in this in some way. Which OS version is that? This is Mac OS 9.2.2, so the very latest version of Mac OS 9 from 2001, I guess, at least according to this copyright here. And it's running on this little Power Mac G4 you can see in the picture on the left below my face. But eventually this stuff should run on my iBook that I'm gonna bring to performances. That is at least the dream. we'll see about that once I get the iBook. Nice, refreshing to see someone using retro stuff. Yeah, I think it is refreshing too. I mean, I have a lot of nostalgia for macOS 9 because I grew up using these Macs from this era, and yeah. I also think just the interface design is really nice. Like this whole platinum thing, it's, I don't know, looks nice. What I don't like so much is the parts that try to look like OS X inside macOS 9, like QuickTime Player. But yeah, I work a lot with contemporary SuperCollider on macOS 10 and Linux and sometimes even Windows. But I have been doing some retro computing streams with various topics like 3D modeling, or maybe more like 3D creating a scene, not so much modeling, I guess, with Bryce 3D, and then there's been some other stuff like programming C++ with macOS 9 tools. I didn't get super far with that yet, but it's another thing I would like to continue with at some point. But yeah, then I found out that SuperCollider 2, which is this older version, was available for macOS 9, and I just had to try it out. Like, what was Algorave or like music programming like back in those days? And I have to say I quite like it. Oh, checking my GitHub YouTube algorithm through your live stream. Yeah, anything interesting on the GitHub? There's a lot of half-baked stuff on there. I wonder how difficult it would be to code retro skins for current SuperCollider versions. Yeah, that's a good question. I think from what I heard, the GUI stuff in current SuperCollider is kind of threatened right now by, I think they use Qt, if I don't remember incorrectly. They use Qt, and I think that is becoming like unsupported in general in the near future. So to keep the SuperCollider GUI stuff relevant, I guess there's gonna have to be a large porting effort to something else. And I don't know if anyone is working on that. It is probably quite a big effort. Though I guess the Qt stuff does currently work pretty okay and is gonna do that for a while. But at some point it might become difficult to build. I don't know. Yeah, that's just something that I heard of, and it worries me a little bit, like with regards to the future of SuperCollider. Though personally I don't even use the GUI stuff that much. I mean, I don't even use the IDE anymore. I run SuperCollider through Emacs, so maybe in the worst case, SuperCollider would just have to drop the GUI stuff and remain as a non-graphical application, but that would be a pretty bad downgrade because there's a lot of code using the GUI functionality. You tried running SuperCollider through VS Code, but some stuff wasn't working that good. What stuff is that? I haven't really used VS Code myself, but from what I understand, the extension should be usable. Yeah, for Emacs I use SCEL, as it's called, SuperCollider Emacs Lisp, and it's fine. I think I had to make some modifications to it myself. I don't remember what for anymore. And of course, that tends to help with issues if you have the ability to go in and mess with the code yourself. Like, the way these extensions work in the end is just running the sclang command line application and passing your code to it. Syntax highlighting and autocomplete issues. Right, yeah, that could be a problem. Yeah, I guess there's... I don't actually know how that works in VS Code. Probably they have like their own like syntax table or whatever that does the highlighting, and yeah. SuperCollider is a bit of a weird language, so I'm not surprised that there might be bugs in the highlighting. Actually, I think there are some bugs even in the Emacs one that I use. But, you know, it's not the end of the world. It gets it mostly right for me. And yeah, autocomplete can also be tricky. In Emacs, I mostly tend to use, like, okay, so in Emacs you have a company mode, which is like one of the popular autocompletion systems, and company has different backends which determine how the thing you're typing gets completed, and one of those backends is like a very simple one that basically just looks in your file for, I guess, different names without caring about really their semantic information, like is it a variable, is it a function name, is it a class name or something like that, but it just takes all of those identifiers and then suggests them if they match the thing you're typing. And it's kind of crude, but it works with a lot of different languages and it doesn't take any setup, so I don't know if there's something similar for VS Code, but I tend to like that. Apart from SuperCollider, do you use any other scripting music programming language? I've tried Tidal as well, and it's cool, more performance-oriented. Yes, absolutely. I also use Tidal. You can find some of my Tidal performances on my YouTube. And yeah, Tidal is actually what has, or my Tidal setup is what has served as the inspiration for what I'm building here. So for Tidal, I also have this setup where using my MIDI controller, I can, you know, start different patterns by pressing these buttons, and then these buttons are also knobs, so by turning them I can tweak different parameters in the Tidal code. And what that means is that the way I tend to perform is that I write some pieces of code in advance, and then I perform them by mostly not even touching the keyboard, just like triggering things on the controller and tweaking stuff. And I find that quite nice. It helps with musical timing compared to having to type a bunch of stuff and navigate through code. But yeah, so that is basically what I'm trying to recreate here with SuperCollider 2 as well. So yeah, maybe I'll just demonstrate that again. So if I play this back, it apparently doesn't work. Oh, there we go. So, for those coming in a bit later, just to repeat, I have an emulation of this MIDI controller on my phone right now in Touch OSC, just because I cannot connect this controller directly to Mac OS 9. But here I have these buttons correspondingly, so with this code I've now set up, there's 4 different patterns, which create 4 different like synths, and I can trigger them by starting these patterns from here. So the idea is to build a live performance system with the same kind of workflow as I use in more modern Tidal, but running on OS 9. So it's come along quite far in the past 2 days, which I'm really happy about. So I think after this stream I will be ready to actually start composing with this system. Do you use instruments you've built in SuperCollider in terms of sounds? Yes, that is mostly what I use with Tidal. So I have a number of synth defs I've defined. Sometimes I will use external MIDI instruments. For example, in the Algorave 10 years performance that I did, I had MIDI output going into a Game Boy, which was running MGB, and then I was getting like chiptune sounds out of that. So I was sequencing the Game Boy with Tidal patterns. And I have a few hardware, like other hardware synths as well, but honestly, these days I haven't been using them that much, which is mostly because it's hard to find the space for them here in my workspace, which is kind of chaotic. But yeah, I use SuperCollider synth defs with Tidal and also, of course, a lot of samples. Yeah, some examples of synth defs I've made are like Psytrance kick synthesizer, Psytrance bass synthesizer. Then there's a 303 emulation, kind of very rough around the edges, but it does the job, which I actually pulled from sccode.org and adapted it for Tidal. Some pad stuff. There's one that takes like it's basically a recording of breathing, and then it filters that through a bandpass filter, which is tunable, so you get this kind of interesting resonant sound. It would of course make sense for me to showcase these, but I don't currently have this streaming set up for showing stuff from Mac OS 10, so another time. However, yeah, there is actually just one more thing that I really would like to do with this system that I've been working on here, and that is in SuperCollider 3 there is a pattern type or class that is called place, where the lace stands for interlace, I guess. And so what it does is, if you have a pattern like, okay, these are just gonna be random numbers now, but so if you write something like this, and I guess you wrote it like this, place, so yeah, one of the values you'll see is an array, and you can actually have nested arrays, but the way this works is that you'll get 0, 1, 3, 0, 2, 3. So, you know, every time the sequence hits this value, it takes one of the elements of it and then moves like an index specific to this value, increments that by 1, so that the next time it will take the second value and so on. Yes, and in fact you can nest that stuff, so you could write like this, and then you would get 0, 1, 3, 0, 2, 3, 0, 4, 3. I think that's right. And this is very similar to something that Tidal has, which is, yeah, I guess you use these angle brackets, and then you can do essentially the exact same thing like that, I think. Although, yeah, the way you have to manipulate durations in Tidal is a little bit different. But yeah, so this is something I use a lot. I find it a very nice way of writing melodies, both in terms of just like designing, okay, I want to repeat this thing, but then I want to tweak this one note here on the second repetition. For that, this is very nice and compact. Another thing you can do with this is just throw in values more or less randomly and have it work in a generative way where you can't really predict what's going to come out, but then it might sound nice, and yeah, happy accident. Yeah, very interesting for composing. Could do pseudo-random melodies or rhythm. Yes, exactly. Like Steve Reich stuff, or I don't know, that kind of vibe. Yeah, I imagine so. I don't know a lot of Steve Reich work, to be honest. But yeah, I heard the one, I think it's called, is it Piano Face? And that was played on like, what was it? I think it was this floppy drives or something that were mounted in these metal resonant frames, and then, because you know, people make instruments that are like motors basically spinning at different frequencies, and then you get sound out of them. So it was something like that. It was a few years back. Yeah, there's also a similar violin piece with the phasing thing. Ah, I see. Yeah, I don't think I've heard that one. But yeah, the question then is, what should this look like in terms of usage? And a mic feedback piece. I like these kind of random beat patterns that the phasing creates. Yeah, it's quite nice. At least, yeah, the one I've heard, the piano face one, I really enjoyed that. Yeah, I guess you can get something like that with mic feedback as well. Mic feedback just makes me think about the, what is it called? I Am Sitting in a Room by, is it Alvin Lucieri or something like that? Mic swinging near speakers. Ah, I see. Trying to imagine how that sounds, but yeah, I guess it depends on the source material, but yeah, with the reverb feedback, or like the, yeah, room reverb, it's kind of cool how it iterates and devolves into these room resonances basically at the end. Yeah, it's one of these, I don't know, I guess it's like a piece you're gonna hear if you go to some sort of contemporary music school. I think I heard it in, I don't remember what the class was, but when I was studying at the Sound in New Media program in Aalto. But yeah. But to come back to this pattern, so what I was thinking is that, okay, one way to approach this is that we would have some kind of preprocessor that would turn, for example, this into just a regular one, or like a flat array with the interlacing thing. But the problem here is that if later I want to implement polyphony so that you can have, well, so that this could also stand for polyphony, then of course you have like an ambiguity here. So if you support polyphony and interlacing, then which one is this? And how do you differentiate between the two? And also the implementation I'm proposing here, where this kind of thing gets turned into a flat array, is probably the simplest way to do this, but I don't really like it, I think, because you have the potential for really blowing up the size of the array. Because now let's say I go in here and I have a sequence of 3 values, then to interlace this all together, I think you have to do 2 times 3 times the length of this entire sequence. So that would already multiply the size of this sequence by 6, which is not that much really for a computer, but yeah, I guess it might be that with practical sequences it's fine to blow up the size that way. Like, it's not gonna be a problem until you hit, I don't know, like even 1000 should probably be fine. Because I guess indexing this is gonna be constant time anyway, so it doesn't really matter how big this is apart from like memory usage. And I mean, we have an amazing 1 gigabyte of memory. Are you thinking of choosing the polyphony function on purpose? Otherwise, I don't know how the language can interpret the matrix as a collection of nodes to be played together or parse it. Well, yeah, that's the thing. So right now I don't have polyphony, and that's, well, I do have it, but you have to do it by entering 0 durations, and that's kind of unwieldy. So for example, in this case, these 2 notes will sound together because there's a duration of 0 between them. But I was thinking that it would be nice to have a way to express polyphony inside like one pattern, and actually any pattern. But then it would also be nice to have the interlacing thing. So yeah, the thing I'm wondering about here is how to disambiguate between the two. the more I think about this, the more I feel the gravitational pull of the SuperCollider 3 pattern system, which is based on streams. So maybe what I should be doing is implementing streams as they are in SC3 and then basically translating the same way. I'll have to think about it. Otherwise, are all these patterns kind of like assigned in one voice? Otherwise play different patterns which are the same simultaneously. So the streams is different from this version. So it's not one voice. So what happens is that, let's see, where is that? Yeah, so what happens is we end up creating this spawn ugen. And spawn ugen is an interesting one. It's something that I think doesn't really have an equivalent in SC3 because of the whole client-server architecture. But what it does is it takes a function that it calls repeatedly, and how often it does that is determined by a next time value that is internal to the spawn and that you can also adjust on the fly inside the function that you give it. So this eventify here is actually returning one of those make event functions that spawn deals with, but it's not limited to one voice, and that's kind of the cool thing about this. So it creates events which there can be like any number of, they can overlap, and so that means you can have polyphony, arbitrary polyphony inside of this spawn, as long as you set up your make event function correctly. And that's nice. It means you easily get, for example, even if you have like a monophonic melody, you can get the notes to decay so that they overlap with each other, if that's what you want. But yeah, play different patterns which are the same simultaneously. I mean, that would be one way to do polyphony, but then you have to repeat a bunch of stuff, at least in the way this is currently set up. And yeah, streams is different from this version in that I don't think there is a stream class at all here. I could be wrong, but that's what I seem to remember. Yeah, that doesn't exist. So the thing is, I don't know if I want to go just the route of re-implementing SuperCollider 3 streams, because, okay, it's powerful, it's a good abstraction, there's a reason why they did that. I'm very used to it, so that's nice, but if I'm just gonna re-implement SuperCollider 3 stuff, then what is even the point of using SuperCollider 2? You know, so I kind of like that this here is a little bit different and inspired by SC3, but still kind of my own design, so maybe I can find a way to fit both polyphony and interlacing into this model as well. But let's say Okay, let's say I don't care about polyphony at this point. You want to have the inner array parsing as in the place thing you showed, PLA's thing you showed, but also use the array as a polyphony structure. Yeah, I would like to have both and some way of differentiating between those, so maybe it could be like okay, maybe this would be polyphony, but then if I wrap it in something like a lace object, then it would do the interlacing instead. That's one option, of course. Though how to implement then the conversion from that to well, basically the stuff that the spawn function deals with, or the usion deals with, is another question. But yeah, let's say for now I do not care about polyphony, because I can technically already do it by messing with this durations, and also actually, yeah, this is basically the latest thing I implemented, so a way of bundling things together. So instead of writing these as separate patterns, it is now also possible to write like a list of lists. And this works by noticing that, okay, the key here is a list, so then we process this differently. So the nice thing about this is that this actually makes it easier to write polyphony, right? Because now we could set these to 0, and then that kinda gives us a clear indication that, okay, this is one chord in this case that will play all simultaneously. And actually, I wonder if it would make sense to convert the other kind of polyphony syntax to this somehow. I don't know. But yeah, so I think when it comes to polyphony, I'm happy with the way this is now, and so I really only care about the interlacing at this moment. I don't know that much about SuperCollider, but could you like define the same array structure in something like a function with an if statement? One root being the array on its own and the other with the 0 durations included, so it's polyphonic. But that would mean you would have the whole structure written many times, not ideal. I'm trying to like visualize that in my head. Yeah, maybe if I understand what you mean. Yeah, I'll think about that, and for now, like I said, I will not care about the polyphony, so I'm just gonna try to see if I can easily implement interlace or lace. So, okay, this is already pre-processed and converted into like this kind of dictionary. So I can modify this pattern and start adding the interlaced stuff here. . let me listen to this one again so I remember how it sounds, because I'm not good enough at reading MIDI note numbers to like oralize it in my head. Okay, I'm gonna first duplicate all of this just to get an idea of what I'm trying to achieve, like musically. So I think 89 is the note I want here at the end. Maybe not, maybe 87. Yeah, this is better. So, I would like to be able to write this as a much shorter version, which would be this. And how can we do that? I'm gonna go ahead and start writing a function to just brute force expand the things. Okay, so we'll call it lace expand, and then X is just gonna be our example array. So we're gonna start like this. And eventually we'll want to lace expand of X and post the result of that. Okay, so we get as an argument the array, or it might be a list, I don't know. I'm gonna call it array anyway. Actually, I'm gonna call it list because it's a little shorter. So I guess I think we will want to create a whole new list. That is probably gonna be the easiest way to deal with this. We're gonna return that eventually. We're gonna go through the list. how would it index that natively start from 1 and have 2, 3 as second item as and 4 as third? Yes, exactly. So we can see that by taking index 1, and there we see that we get the whole list that is in there. We're gonna get a value, and probably we're gonna use the index for something. Basically what we're gonna want to do here in some form is gonna be the Cartesian product of all the lists that are inside lists. I think so, at least. So, okay, let's step back and think about Cartesian products. I wonder, it could even be that there exists a function for that already. Not classes, let me go to the main help. So we have collection, I guess. Oops. Add all, remove all, includes any, select, reject, detect, inject. Any count. Okay, maybe we don't have a function for that. It's been a while since I implemented Cartesian product. It's very easy to do in Haskell for the reason that you have the list monad, but that doesn't apply here. So we'll get a bunch of lists. Well, I need the Cartesian product because basically, okay, let's say our X actually looks like this. Then in this case, no, wait, is it the Cartesian product? Yeah, it is. So from this list, I would take first of all the items that are lists, so I would end up with just these things. And then separately I'm thinking about all the items that are not lists, and then in place of the list, let's say there are these placeholders like holes. Then if I take the Cartesian product of these two lists, that would give me 2 and 5, 2 and 6, 2 and 7, 3 and 5. I think I pressed some wrong button. There we go. Yeah, if you accidentally press Command 7, then your post output is gonna go somewhere else. Usually this window you have selected. Yeah, so the Cartesian product would be this. And when I have this and this, then I could create the resulting list by going through each of the elements of this list and repeating this list with the holes filled in by the elements of each of these. So I would first consider 2 and 5, then I would get 1, 2, 4, 5. Then I'd consider 2 and 6, except, okay, now I have the order. Wait. I see, so you need a way to first separate the inner arrays from the original. Well, yeah, that's easy enough to do on its own. I'm just thinking abstractly, then what do I do with the arrays? Actually, Cartesian product is not the right thing, because okay, let's say our array looks like this instead. Then, or like the arrays within our array look like this. Okay, why did I edit this? Let's consider this row. So then we don't have the elements with 7, but the Cartesian product would look like this. But this would be wrong, because now if our original list then is this, then what we should get by stepping through this is 1, 2, 4, 5, 1, 3, 4, 6. So then basically only this element 2, 5 and this element 3, 6 are valid, because on each iteration we're stepping kind of like, how do I say this? In sync, or these two are gonna stay in sync because, yeah, both of them have 2 elements. So then we would have, instead of Cartesian product, something that gives us this. Okay, I can make that. I think... what should I call that? It's not Cartesian, but I'll call it lace product. And this is not even considering the possibility of having nested lists yet, But I think if we can do this for like one level of nesting, then it should be possible to apply that repeatedly to flatten like step by step. Okay, lace product. And we're gonna test that, not lace expand yet. So what I will do is declare a variable indices, and this will be an array with the size hold on. Yeah, it'll have the same length as lists, and each element will start off being 0. And there is a while loop, right? Or like some kind of loop that is not tied to a particular array. Yeah, while is here. While test func body func. Okay, yeah, that makes sense, of course. While something, we will go through each element of indices. Okay, I'm gonna call it actually counters, because that is what this is really. So we're gonna have a counter, and we're gonna have the index of that counter. Counters.do. So we will increment counter by, oh, I guess we have to do counters I counter +1, and then we will do modulo lists at I, and yeah, I can't actually use this syntax, so it has to be put I. There's a parenthesis like that. So we're incrementing each of the counters by 1 and taking it modulo the number of elements in the sublist corresponding to that counter. That is what this line is doing. And we will need to do this until we reach a state where all the counters have reached 0. But that's also the state we have at the start, so we need to consider that. And also, I don't think we can do this. Declaration must be in a separate line. Okay, I'm gonna make I'm gonna call this not first, which starts off as false. No, wait. it's better if it is first. True. So while first or any element of counters is non-zero. Counters any, I think. Yes, greater than 0 works. So while we are either on the first iteration or there is a counter that is not 0, we repeat this process here. And also we'll want to set first here to false so that we can actually keep track of whether it's the first or not. And okay, I think this gives us the loop structure that we want. But then we need to do something inside that loop, so let's make a result list. Result is just an empty list. Or should we actually use... I'm not sure if square brackets is a list or an array, so... Okay, I'm just gonna assume that it can grow. And then if not, I have to look at something else. Just sanity checking here, so... var x is empty list, x dot add 1. This should work, right? Wait, that does not seem right. Okay, so do we have to do it this way instead? Yeah. Right, so they are not growable. Okay, but this is fine. Yeah, so we have the counters, and now in here actually I guess first of all we will add an empty list to result. Wait, does that make sense? I think it's actually easier if we don't do this so imperatively, but instead counters collect C, and then we take the cth element of lists. No, wait, what? I'm confusing myself here. So lists is something like what we had here. Oh, well, actually, at this point, we just want this. So then counter starts off as 0, 0. Oh yeah, here we want the index as well. So we want lists at I at C, I think. does this already do it? Well, not if you have errors. Oh yeah, I keep forgetting this. In SuperCollider 3, you can leave off some parentheses, but not here. I get what you're trying to do, as the syntax is so confusing though. Yeah, I don't know. It's very different from other languages. Non-Boolean in test. Wait, but what are we then testing? So it's collection any. Am I using any correctly? It's very much possible that I'm not. 1, 1. Okay, that does give me true and false. Okay, so that's not incorrect. Does this work as I expect? So list size, let's just put here something like 1, 2, 3. Yeah, that's the thing I expect. It's very strange. What am I doing wrong? Says non-Boolean in test, but I don't see how that can possibly be the case. Okay, let's debug by printing stuff. Counters first, result, post line. This will just be start. Then on each iteration here we'll do the same. It's gonna be inside the while. Okay, so we do get inside the while loop here. What do we have after the add? Yeah, that looks correct so far. Well, after increment, what do we have then? Oh, yeah, that definitely does not look right. So counters becomes something weird. hold on, so maybe I'm misunderstanding how put works. Array fill 3 zeros. X put 1, 2. No, that does what I expect, so it changes the element at index 1. Oh, okay. I'm missing a size here. Now that looks better. We didn't get an error actually, so that's very nice. But I'm not sure, did we get a result? Oh right, we cannot have the caret, I think, here. That's only for class method return values. Alright. So we had 2, 3, 5, 6, 7. And we get 2, 5, 3, 6, 2, 7, 3, 5. Yep, this is looking correct. Nice. So then, next step. What is the next step? I guess we'll want to write lace expand. And now in this case we're gonna have something like this. Wait, what happened there? So we'll first get the sublists, so that would be all the elements of lists which are lists themselves. How do I check whether something is a list? Might have to use response to, or wait, what was the object here. Is kind of. Yeah, that would be one way. Maybe response to at. Because I guess a number is... Oh, a number will also do that. What is something that only lists and list-like things have? You can treat it as a list and check size. Yeah, I could, but then there is the issue of empty lists. But then again, I don't know if empty lists make any sense in this context anyway. Like, what if we have something like this? What does this even mean? I think this is something that should just be filtered out. But, okay, let's for now assume that we don't have those kinds of things. So, Sublists. I think it is not filter. But was it select? argx x size is greater than 0. Yeah. It should, but in the future empty could mean like pause in the musical context, like duration or something. Yeah, we actually already have a way to denote rests, which is with this R symbol here, so I don't know if I would want to repurpose the empty list for that. If anything other than the R symbol, I would use a nil. But either way, let's just ignore that case for now. Yeah, so sublists equals list select size greater than 0. And then yeah, then I also want this kind of structure with the so-called holes. So what would this actually look like? Like, what is a hole? I guess it could be a symbol, but then it would have to be like another special symbol that I have to deal with. Okay, what if instead we represent this as well, I was thinking this, but then how does this indicate that there's something that goes after the 4? Maybe it doesn't need to. I'm gonna call this pieces, so this will actually be okay. I'm gonna think about the case where I have pieces and I have, let's say, something like this. So the pieces in this case would be pieces would be I'm gonna put actually a 0 here just so we have some variation in the number of consecutive things of the same kind. So the pieces would be 0, 1, and 4. And the product, which is something we would have obtained by using lace product, would be this thing right here. So how do we combine these into the final result? Well, we collect over product. I'm gonna call this argument betweens, so those are the elements that go between pieces. However, I now see a problem here, which is that from this we don't know whether the first element of product should go before or after the first element of pieces. I think there is a better way to do this. So instead of pieces, let's say we have an array called product indices. And this is gonna be the indices of the original list at which we are replacing elements with elements of the product. So in this case that would be 2 and 4. Then, okay, let's bring in our original list. Also, this is not really true anymore, I should fix that. Product collect, product vals is better name. I think we will need the I here. So I'm trying to do this functionally, but I'm not sure if that's actually going to be any easier. And then you can cycle through the original list and increment the product arrays where the product indices match. Yeah, I think it's the same idea, but maybe a little bit different. So what I would like here... Okay, let's say I do this in a very unperformant way. In each of these cases I would copy the entirety of list. Actually, how do you copy a list in a SuperCollider? Can I just do copy? Yeah, okay. List.copy, and then sublist is what we're gonna call that. Then here we will what will we do? Yeah, I don't actually even need to either iterate through that. I can just iterate through product indices to arg product index, and then I can say sublist put product index no, I think I'm gonna need this index here and actually no, maybe not. Yeah, and then product vals at J, maybe. Oh, command P. Oh yeah, and then we want to return sublist here. Oh. Okay, so now we get 2 and 5, 3 and 6. Yeah, that's looking right. And then if I replace this, or if I add a 7 here, then we should get a whole lot more elements. Hold on. Oh yeah, it's because I hard-coded the product here. 2, 5, 3, 6, 2, 7, 3, 5, 2, 6, 3, 7, and then we loop back. Yeah, then we get a whole lot more items, but that's fine. And we'll want to flatten this. Yep. Okay, that is starting to look like the correct logic, given that we have some things. So we have sublists, we don't have pieces, but how do we compute product indices? Well, that's just the indices at which we don't have a list. No, wait, sorry, at which we do have a list. Maybe I'll call it sublist indices. It seems to make sense, because that is what it is. Now I feel like we should have done this in one loop, but whatever. Oh no, it's not a select, it's gonna be no, it is a select, but wait, is there something that lets you do select and collect at once? I thought I had the collections help open, but apparently not. Collection. Huh. Okay, but we can do it such that we first collect argxi, and then we just return the index here, and then we select where list at I dot size is greater than 0. Sublist indices. Okay, then we can start making the result. Oh, and we should make the product as well. Product that is simply gonna be place product value sublists. And with that, we are pretty much done after I just port over this little bit of code. We don't need a result variable, we can just go ahead and do this. Product collect. Product val sublist. Product indices, that is now called sublist indices. Yeah, maybe that is it. No. Let's see. 1 nil 4 nil. Why are we getting nils? Okay, first of all, let's add some debugging. Print again. Sublists, sublist indices, and product. Oh yeah, we'll want to post line that. Okay, so sublists is for some reason empty. Why? We only have one argument and then the rest are variables. Is that what broke it? No. So sublists continues to be empty for some reason. Oh, wait. What even is s? X dot size. Alright, this is starting to look better. So what was our list? 1, 2, 3, 4, 5, 6, 7. So 1, 2, 4, 5, 1, 3, 4, 6, 1, 2, 4, 7. Yes. It is working. Oh, sorry, I didn't notice there were some comments. I got carried away. Being the product from your previous function as a single list. Should iterate through that. Oh, never mind, you got it. Well, yeah. This is a nice stream, very informative. Well, I'm glad you feel that way. I sometimes feel like I'm banging my head against silly things for way too long, but maybe not. To be fair, it is 4 AM here and I've been streaming for a number of hours, so maybe not in the most effective brain state to design algorithms. But hey, we got there anyway. Oh, it's 4 AM there as well. Are you also in Finland? You don't have to answer that if you don't want to, but curious what time zones are the same. Or like what countries are in the same time zone. Oh, Greece. Cool. Yeah, apparently we have the same time zone. Yeah, I know roughly where Greece is, but I'm not that good at geography, so I wouldn't have guessed that. But yeah, that's cool. Okay, so now I want to convert these to methods of my kitchen sink class here, which is called Pulu. So let's do that. I guess they can go here. Don't need the var anymore. We'll get rid of the equals sign. I'm gonna go, but again, nice stream. Catch you another time. Alright, yeah, thank you, and thanks for being active in the chat and working through this stuff with me. It is always very nice to have other people with me when I do this. And yeah, hope to see you on a future stream. This is a static method, so I'm gonna put the asterisk there. Same thing goes here. Oh, and also we need the caret in this context. And then we'll work on some indentation. I think we can remove the post line now. And once again, we need the caret. Okay, compile. Lace product not defined, that's because we need to qualify it with this, and also we don't need the value here. Okay, compile done, so now I can presumably remove these and try bulu.lace expand of x. Yes. Okay. That is pretty cool, and now I'm gonna consider the case where we have nested lacing. So what happens now is it expands the first level, but then there's an additional level. So the way we can think about this is, okay, well, just to show you that if I just call this again on the result, then we get the fully expanded list. So in terms of computer science theory, or mathematical theory, I guess, what we want is the fixed point of lace expand, which is lace expand applied repeatedly to its argument until it no longer changes the result. And yeah, that's the mathematical formulation of it, but really okay, so we could implement a fixed point operator, basically, but then that would have to every time check equality of all the elements, but in our case, that's not really what we care about. What we care about is, does the result have lists in it? And if yes, then we lace expand once, and then we repeat the same question, does it have lists in it? If yes, lace expand, and so on. If not, then we just return the result. So I'm thinking we could maybe build that into the result here. Okay, what if we make lace expand, actually we'll call it lace expand once, and in the case that there is not a single sublist, we're gonna return nil. So that's a good signal for another function which is going to use this. So if sublists, do we actually have an empty function? Maybe is empty. Okay, yeah, we do have an is empty. Do we have non-empty? No. But is empty is fine. So if sublists is empty, or it could be sublist indices, it doesn't really matter here. If it is empty, we will simply return nil. Otherwise, we go through this whole thing. Oh. Oh yeah, the flatten goes in there as well. Like so. And then we just close that. Okay, let's try that. Recompile. Place expand once. Yeah, that works as expected. But let's say instead of x it was just like 1, 2, 3. That would give us nil. Okay. And then we can go ahead and write our place expand arg list and how do I formulate this? It's gonna be some kind of while loop. While, I guess we're gonna have to have a result variable. Oh, not an argument, but a variable. Result. Basically I want a do while loop here, but I don't think we have that. So, gonna be a bit of a repetition here, but that's fine. Result is this place expand once of list. And now it cannot be quite like this, I think. We'll make a variable called new result. So result starts off being list, and what we'll do eventually is return result. But new result is gonna be place expand once of result. And now our while condition is while new result is not nil, then we keep expanding. Okay, so new result is not nil. That means we reassign result to be new result. And new result, we again do this place expand once result. And that should take care of that. Compiles fine. And now we try to run it. Yes. Fantastic. And just checking that if we don't have any lists in there, then we just get the original. Yep. Ah, wonderful. And now that we have this, it occurs to me that we don't actually have to build the lace expansion logic into the stuff that deals with patterns, because what we can do now... Oh, wait. Okay, I was wrong about that, because we're not... Right, so the reason I said that was, let's say we have a pattern like this. Now in this case I could just say pull lace expand that, and that would take care of everything. But that is not gonna work when we have those combined patterns, namely this one here. Question I have is, what happens if I run lace expand on something that's not a list? Yeah, that doesn't work, because non-empty is... Wait, what? No, not non-empty. Yeah, select is not gonna work there. What about... So then maybe we do want to build it into the pattern processing stuff after all. Okay, where exactly would that be? Would that be in Eventify raw? Does it make sense to apply lace expand to everything? No, that's the thing, it does not. Because it's perfectly conceivable that we would want to pass arrays as values to something and not have those be expanded. So okay, we can solve this by making another version of lace expand that operates on these. So we would be able to do pull lace expand multi, for example, and then Does that work? Yeah, I'm kind of struggling to wrap my head around how it should work in this case. Because basically I think we would have to unzip all of these lists, then apply lace expand to each of the unzipped lists and then re-zip them. But for example, in this case, we would end up with different lengths of lists after applying lace expand to the unzipped lists. So I'm not sure quite how that should work. So probably here is where the decision not to go for the SC3 approach of streams comes back to bite me. Okay, I can't think of a really hacky way to implement this. But the question is, do I actually want to do it? I'm not even sure how to explain it. Okay, I'm gonna try to work through an example. And in fact, at this point, we can remove quite a lot of this stuff. So let's say we have this list of lists, and in this element we have something like this. Okay, so the first step would be to unzip this, which means we would end up with if you think of this as a matrix, then where it is pretty much just like taking the transpose or transposing the matrix, however it is that you say that. 0, 25, 0, 25, 0, 25, 0, 2, 0, 4, 0, 6. Okay, so far so good. Then if we would apply lace expand, we would end up with something like this. Uh, 80, 75. And yeah, this is a problem because now we have different lengths of lists. And you might think at this point, well, what if we just repeat the two other lists? but okay, consider that we also have a lace here, and it's gonna go like that. So now that corresponds to this element. And then what happens here? Well, we get 0.25, 0.25, 0.25, 0.25, 0.5, 0.25. And so now we can't really get away with repeating lists because the length of this list is not a multiple of this. Okay, and now if you have some mathematical background, you and your thoughts may be going where mine have gone, which is least common multiple. So we would have to compute. Do we actually have LCM or something? Yeah. So in this case we have 6, 9, and 3. Okay. 6, LCM 9, LCM 3. So that gives us 18, which tells us that we would need if we go through 18 elements, how do I say this? If we step through each list one element at a time, wrapping back to the beginning when we reach the end, then after 18 steps we would have reached the end of all the lists. So we're all the, yeah, you get it, I think. Which then would allow us to create a list of lists which all are the same lengths by repeating each of these lists by an amount that is this number 18 divided by the length of this list. That way we end up with 3 lists that all have length 18. And then we can re-zip. And I mean, that's kind of terrible. Just thinking in terms of the potential for like combinatorial explosion here. But it's fine. Let's do that. So also, is there like a reduce operation or fold or whatever? Reduce not understood, fold. Fold not understood. Oh, do I have to implement a reduce or fold operation. Right, the neutral element of LCM is 1, right? Yeah. Well, let's implement fold. Why not? So it will be like this. I'll call it fold left because it is a left fold that I'm interested in. Arg, we have the list, we have the function to fold with, and we have the 0 element, we'll call it C. Now, we will have a variable called result, which initially is C, and we're gonna return the result eventually. We will go through the list. Calling each element X, and we will make result the value of F applied to Z and X. Okay? And with that we can say fold left value. Well, let's use our actual example. So we have 6, 9, and 3. Our function's gonna be arg AB, a LCMB, and our 0 element is gonna be 1. And that did not work at all. Oh, because, yeah, we want result here and not C. Okay, 18. Good. We'll put the fold left function in pool. Maybe one day I'll reorganize these so that not everything is in one class, but that also means I'll have a lot of code to go change, maybe, to adapt to that. Okay, we have fold left. Now what? Okay, now we can try making basically this. Let's just write down our other steps. No, let's just start coding. So var lace expand multi. Actually, before that, we have integer division. Oh, well, that's common syntax, so probably not that way. Div. Yeah, okay. Good. Yeah. Let's expand multi. and that will be a function that takes a multi-pattern, as I'm calling it now. And arg not var, then unzipped, that will be should I actually write zip and unzip functions? I don't know. Maybe it's not necessary. But, okay, how would I approach this? I think I did something similar at one point already. Okay, maybe I will write an unzip function, because doing it inline here is, I think, gonna get a bit messy. So comment this out for now. Unzip. So let's go one piece at a time. I mean, that's just good software engineering, right? I think I'll have to do this kinda imperatively again. So var result. Result is, what is result? We'll initialize it to a bunch of empty lists, but okay, actually before that, if lists is empty, then I guess unzipping the empty list of lists is just the empty list. Otherwise, we will initialize result. And now the nice thing about this is we know we have at least one element in lists. So we will take the size of that. How do we make that happen? Let's go with... Is there, by the way, a first function or method? Yeah, there is. Okay, cool. First, collect, and that's just gonna be a bunch of empty lists. Yeah, I'm really starting to get a bit tired, so it's not the easiest stuff to think about at this point, but I will put on some background music, which maybe helps a little. So I feel like I'm missing some kind of obvious way to do this. It's kind of taking shape in my head, but it's not the easiest thing. So if we have something like something like this, we take the first one, maybe we'll give this a name. At the end we're gonna want a list with 2 elements. So we go through X first, collect, we get L, the sublist, and I, the index. X collect I'm really just giving things very short variable names now to try to work through this quickly. X collect K at I. Yeah, that is how you unzip. So we don't need a result variable, we can just return this thing here. And of course X is in our case called lists. We'll call this whatever because we're not using it. List at I, and we don't need that index. Okay, so now unzip value huh? Nothing. Why is there nothing? Now I'm really confused. Absolutely nothing. Okay. But this we can still post. Why are we not getting anything? Okay, that works. But oh, it's the carrot again. It's kind of weird that it causes like silent failures when not in a class context. But okay. Now it occurs to me that maybe it doesn't make sense to call this transpose, or it would make sense to call this transpose instead of unzip, because yeah. So let's do that, but first I'll put it in the class, because when you're dealing with lists of lists, then unzipping and zipping becomes kind of the same thing, unlike with a normal zip where you have, let's say, 2 lists, then you're creating a list of tuples. And then unzipping that creates, again, a tuple of lists, which you can think of as a list of lists, but in Haskell it's different, so I guess that's where I am getting these ideas from. Anyway. Transpose. Oh, and we had that already. And now we gotta add the carrot. Compile done. Cool. Now, I'm gonna have to check, is there actually a built-in transpose, because that would be really funny after all this. There's not. Oh, there is. It's called flop. So I didn't need to do this after all. Well, hey, it was good brain exercise, right? The fucking collect thing. Okay, we have flop. We are flopping so hard. Yes, that is exactly the thing I needed. Okay, well, I will just go ahead and rename this to flopped, and it will be multipat flop, of course. I'm gonna syntax colorize so we get rid of the red there. Yeah, flopped, then expanded, flopped will apply bool dot lace expand, I guess. And what does that give us? So this, I think, should give us just the original list. Actually, it gives us nil. How interesting. What about this way? That doesn't give us anything. Oh, right, we need to post line. The reason I keep forgetting that is that there's also a way to print or post the result of evaluating the selection. Eval print selection, Command P. So I'm sometimes running that, but then sometimes I'm just running evaluate and forgetting that it doesn't print anything. Okay. We don't actually want to lace expand this. We want to apply lace expand to each of these elements. Can I do it this way actually? What? And also like that. Select so maybe I do need arg. Yeah, okay. So but I'm gonna try something here. So what if we have a non-rectangular array? Can we flop that? Okay, we can, and it does something kind of interesting. What about this? What? 1, 2, 3, 1, 4, 2, 5, 3, 4. Okay, but it doesn't, it does not do the whole thing that I'm looking for, which makes sense. I wouldn't expect it to. Okay, we have expanded. Then we're gonna lengthen. It's kind of a nice track. I mean, it's my track, so like I'm complimenting myself here, but I really enjoy that part of the track with the chippy melodies. I should make a proper release, or like a proper version of that and release it. Lengthened. In order to make lengthened, we do need the LCM of all the lengths in expanded. What do we call it? It'll just be length. Length, that's gonna be fold left, and what are we folding? We are folding expanded dot collect and taking the size of each element, and we will apply LCM arg AB a LCM B with the 0 element 1. That is cool and all, but first I just want to check that I'm getting the expected length here. So what do we expect based on this? I think we expect 3? No, 2. Oh yeah, because it's, yeah, the length of this whole thing. 2, yes. But then if I have here something with lacing, it doubles to 4. And if I have something with 3, it should go to 6. Cool. And then if I have here something with 2, it goes to 12. If I have here something with 9, it actually shrinks back to 6 because these are now kind of in lockstep together. Okay, length is behaving as I expect. So then length, and that will be, we collect over expanded. Oh, by the way, how do we repeat an array? Is that something? Repeat is not understood. I don't think we can do multiplication either, like in Python, because that's just element-wise. Yeah. I am pretty sure there is something for this, but what might it be called? Well, it's not here. Let's have a look inside. Common collections. Maybe list, I don't know. To see if there is something. Sequenceable collection, yeah, I wonder. Yeah, that's in here. Wait, what is this? Unlace? Oh my god, don't tell me that is what I have been writing. Okay, maybe not. Normal lists. I don't really know what this does. Okay, that's weird. Is there something called lace? That is the opposite of unlace. I'm just trying random stuff out now. I'm gonna search in here because I'm really curious now. There is only unlace. Well, sure. Also, I'm finding out now that we do have something like streams in here. Okay, but what is call stream? Where is it defined? Oh, whatever. What I actually wanted to do was to repeat a list, and of course, now that I think of it, I can do it this way. It's gonna be some unnecessary allocations, I guess, but like, whatever. This is code that's run during initialization only once anyway, so it's fine. Expanded collect. argx array fill. Okay, we're gonna have to compute the number of repetitions. Or I guess that's actually not a lot. So, okay, first of all, we'll put x here and we'll flatten at the end. So what we want here is length, oops, length integer division by, what is it, x size. So now let's have a look at lengthened or not. Oh, again, I'm making this mistake. Okay, and then at the end, I guess we just want to flop. Yeah, this actually is looking correct. Okay, let's go ahead and put that in pulu. Here we'll replace references to pool with this, and we'll add the returning caret. Let's try compiling. Nope. Oh yeah, this goes away. Yep. And with that, we can get rid of all this crap. And this is ready to run. So pause that and let's try this out. Oh, we're back at minus 63 dB for some reason. What was the key command? Command 0. Okay. That works beautifully. I'm so pleased with this. Even though what goes on behind the scenes here is a little bit ugly, but hey, who cares, right? Yeah. Now let's try the case where we add some lace to that as well. And it creates a nice rhythmic variation there. Yes. Oh, it's getting a little late, and it looks like I've been streaming for 6 hours. That is a little bit longer than I expected. Well, sometimes that's how it goes. But we made really nice progress again, even if it was maybe a little bit slower than yesterday. But yeah, pretty much achieved all of my goals for tonight. I'm thinking, is there something I still want to do with this? And yeah, there kind of is. So one thing would be a way to add a little bit of randomness. Oh, there's also another pretty important thing that I forgot about. I was thinking about it earlier today, or yesterday, I guess it is at this point. Namely, support for tempo, which kind of a basic musical thing, you'd think, but yeah, that's currently not in here. So all the duration I have been specifying in terms of seconds, and like mathematically it's just a matter of scaling those, of course, but okay, maybe that can be the very last thing I do tonight. So let us have a variable called tempo, and let's deal with tempo in terms of cycles per second, right? Cycle can be thought of as a bar, pretty much, I guess. Yeah. Tempo. Let's say we want to go at 1.5 cycles per second. We'll not think of BPM quite yet. Tempo. And then that's gonna have to be something we use with play patterns. maybe, yeah, or I'll call it CPS because that's a little less ambiguous, I guess, because the tempo could also be a BPM value. CPS, where does this go? It has to go into pattern spawn, right? Because that's what takes care of timing. So pattern spawn. And then in turn that has to go into eventify. Oh, CPS, not tempo. And here we take the CPS and yeah, so eventify raw has no business knowing about CPS, so we'll need to do the conversion here. And that's quite simple. Here, where we set spawn dot next time, we simply then divide by CPS, right? Now I'm thinking, should this be a multiplication instead? So we invert this somewhere here. Yeah. Var CPS inv. Also, for the future, maybe CPS could also be a function or a ref, so that we can change the tempo on the fly, but let's just think about static tempo for now. So CPS inv is of course 1 divided by CPS, and then we can simply multiply. Okay, that I think should do it. Or not. Variable tempo not defined, but where? Pattern spawn. Wait, that's gonna be... Did I still use the tempo? Yeah, I did. CPS. Oh, and then, yeah. Declarations are separate from assignments. Which is interesting, because with the arg keyword, you can give defaults on the same line. And of course, in SuperCollider 3, you can do them on the same line. Anyway, compile, and now it works. Well, now it compiles, I should say. Let's call this CPS as well. And now if I run this, I think it should be the same tune, but significantly faster. Well, no. Because... what? Oh yeah, I need to declare it here. Okay, now we are running, and let's try enabling some patterns. Here's one thing. The tempo should also be applied to this here. So, okay, here we're also gonna divide by CPS, and now I would like to multiply again, but whatever. This, I think, it's only gonna happen once, so it's fine. And just like that, we have a tempo control. Now, what if we wanted BPM? What is the conversion again? So 1 CPS is 60 times 4 BPM. 60 times 4 is 240. So I guess this should give us 120 BPM. Yeah, it does. Now the thing is though that these are not quarter notes, they are half notes. So I'm gonna add a multiply by 2 here, just because I don't want to go through all the patterns to fix them. Although I really should. That did not work, apparently. Oh. Okay, but let's say we wanted to have 135. So yeah, I was talking about adding some randomness, and well, my first idea was that maybe I have to do it in the pattern somehow, but yeah, for that I don't really have any kind of facility right now. But of course we don't have to do it in the pattern. We could also do it here. So let's add a multiplication. We'll take, wait, how do I get a random number? Is it just 1.0 dot rand? Yeah, I guess so. So if 1.0 dot rand is smaller than control knob 3, or well, it's the fourth one, but index 3, then we multiply the frequency by 2, otherwise by 1. That crashed, apparently. Oh yeah, this needs to be value. Because that's a ref, so we need to take the value to compare it to something. And now, if I show you here, if I adjust this slider, slider number 3, then we should slowly start getting more higher notes. So that way we can get a nice little random element that is also controlled by our performance controls. Yeah, I like to do that kind of thing to, you know, breathe some more life into my patterns. Wow, okay. I think that is gonna have to be it for tonight. So to recap, we made a abstraction for loading samples, so we can do it on a single line like this. It deals with error handling, so if this fails, this returns nil and we get a nice message in the console or the post window. We built a way to make these multi-patterns, so we can group together values related to one note. So this note is note number 72, duration 0.25, amplitude 0.2, and so on. Which is quite nice in some cases. And it turns out this also helps us with polyphony a little bit, because now we can do stuff like set these to 0, and then we see quite easily that we have here a chord of 3 notes that are gonna play simultaneously. We can listen to this just for the heck of it. It's clipping a little because it's too loud, but yeah. Chords, nice. Then we added this way to basically add a static effects section that goes outside the spawn, which spawns these events, and devised, in my opinion, quite a nice syntax for it. So we have this arrow-based syntax. So first the pattern data that goes into this event synth, which then goes into this effects section, and in this case we just have this echo going on here. So that's nice. And then finally, maybe I missed something, but finally we, oh yeah, 2 more things. We implemented support for this interlacing thing. So, for example, here, this node is going to alternate between 86 and 87, and the duration is going to alternate between these three. Well, two of the values are the same, but that just means you're going to get two of those in sequence. And we implemented this both for regular single patterns and multi-patterns. So here it's lace expand multi, which does the pre-processing and expansion of this to a regular flat multi-pattern, and then just lace expand is the equivalent for single patterns. And finally, we implemented rudimentary support for tempo, and yeah, I don't know, I feel like I've been less productive than yesterday, but maybe that's not actually the case. And also, like, stuff I'm doing in my free time, so who really cares about productivity anyway? Gonna try to get out of that mindset where, you know, it's in Finnish we would say suorittaminen, which is like performing, but not performing a music piece, but like performing a task. Yeah, that's not how I want to think about this. This is fun times and enjoyable explorations of SuperCollider 2. And yeah. Oh, and I cannot forget one more thing that we implemented. This class for getting performance control data from TouchOSC, which is what enables me to start and stop patterns on my phone here, and also tweak things using the sliders. So yeah, that was actually quite a significant thing as well, although the groundwork for that was laid by previous parts of this retro SuperCollider saga, where I did basically the same thing, but for the older type of the first type of sequencing system that I made, which was this one. So yeah, we can actually have a look at this. So this is how I implemented sequencing initially, and comparing to my current system, this is very messy, it's inefficient, it's difficult to understand, like what, there's an impulse sequencer, there's frequency, this and that, like, yeah, you can understand this if you look into it, but it's like pattern logic and synthesis logic is kind of jumbled up here, and that's not necessarily a bad thing, but with the way I'm used to writing music, it kind of is a bad thing. So those are separate things to me, and we've achieved that separation with this pattern and make event mapping, or whatever you want to call it. And then of course all the control stuff was basically manual, so, and inefficient, because I was just muting things, and the muting was just by getting, for each of the elements, plug.kr and listening to the ref that changes value depending on what is pressed on the OSC controller. Yeah, then there's this. Okay, maybe in a future part we're gonna try and rewrite this beginning of a track using the new system. Yeah, that's actually something I want to do, because I quite like how this sounds, and if you haven't heard it, I'm just gonna play it for you for a little while. So we have kicks, bass, hi-hats, we have a pad, oh yeah, here's actually something that might be a little interesting in terms of... Okay, well, I'll play the final bit of it, which is the melody. So yeah, I really like how this sounds, and I think it has potential to go somewhere as a track. So yeah, let's at some point try to implement that in the new system. And there might be some interesting challenges there, because that's something I didn't think of earlier, but there is basically a side chain compression going on here. It's maybe easiest to hear if I just play the kick and the pad. Or even just the pad. So yeah, the pad is ducking every time the kick plays, even if the kick is not actually playing, but you know, during those times. And yeah, that's something to see. Like, how can we... how can we implement that in the new system? Side chaining, basically. Okay. Of course, immediately when I asked this, I started to think about it, but I don't want to think about it now. I'll leave that for a future stream. But an interesting challenge, for sure. Yeah, so please look forward to that. Here you can see some of the code that went into this sample wrapper. This is pretty simple. Oh yeah, and one fun thing here was this play one-shot method, which simplifies the task of playing a one-shot of any sample you have. Deals with the duration calculation and all that. Puts an envelope on it. Yeah, and there's just various help files open. Let me close those. MFT pattern control. This is where we construct the OSC tree to respond to various OSC messages. So we have button messages, knob messages, also a special button message, button 15, which is the stop modifier. So if I hold that and press pattern button, then it stops the pattern in question. This kind of stuff, and then play patterns, which takes this control data and kind of injects it into a sequence of patterns, so that each of the pattern buttons on the controller gets automatically associated with the corresponding pattern in this sequence. And it also mixes them all together. so that we are able to write here just at the end. Control play patterns, pattern data, and CPS. Very nice, if I do say so myself. But yes, that's gonna have to be it. Thank you to everyone who joined. Thank you to everyone who joined the discussion. Yeah, I'm really happy with the fact that these past 2 streams we have had people in the chat discussing these things with me, sometimes working together on the problems I'm facing. Thank you for that. I hope to see all of you in future streams, and also more new people, hopefully. Yeah, outros, my arch nemesis. I'm just gonna close these things. Don't save the post window. Close the windows here. Yeah. So that has been everything for tonight. Oh, hi Sverra. Nice to see you here. Unfortunately, I'm just wrapping up, but it was a really good night. Have a great night or day. Thank you, you too. Yeah, it's actually early morning here, 5:47, so I am gonna go to bed, but after that it's gonna be a day when I wake up, whenever that is. Yeah. Yeah, so I'm gonna end by playing a bit of music and leaving my brand new end screen on, which I actually made today. But yeah, see you in a future stream. Good night.